Introduce our presenter for today's workshop. Michael Meth is the Associate Dean for Research and Learning Services at FSU Libraries, and will be presenting on advanced data analysis with Microsoft Excel. Mike, go ahead and take it away.
Thanks, Nick. Thanks for the introduction. Hello. As Nick said, we're doing intermediate/advanced data analysis with Excel today, and as you already heard, I'm Mike Meth. I'm the Associate Dean for Research and Learning Services. So welcome to the session today. I'm going to start with actually what happens after the session before we get into the other content. And basically what I would like to encourage you, if you can, to share your email address with us if you're interested. You can send it to us in a private chat or via Zoom. And what we'll do is following the workshop, you'll get a copy of the slides as well as a workshop evaluation survey. So just wanted to put that out there right now. I wanted to quickly start with my background very quickly, just so you know why I'm here, because although I'm the Associate Dean for Research and Learning Services in the libraries, I spent the first part of my career working in finance and built a lot of Excel models. And so through that experience and everything else I've done, I've learned a lot about Excel. And I will say I have some tips and tricks up my sleeve, and some people think I'm an expert. But on the same token, I will tell you that Excel is so big, so vast, it keeps on getting developed, that really, to be a true Excel expert, there's a lot of room even left for myself to grow. But I do say that also in the context that wherever you are in your own journey, whether you're already an Excel expert or you are just on that starting out part of the journey, we can all learn more. About a dozen years ago or so, I switched into academia, and I joined at the University of Toronto, Mississauga, as the director of the finance lab over there. And I first started seeing how Excel was being used in academia also for research. And so some of what I'm going to show you today is going to refer to examples from data sets that you might download if you are either in the finance or economics field. But we'll take a look and we'll get more into that when we get to those slides. What I want to do next, actually, we are a smallish group. There's 3 of you here that I see, and I know at least one of you. So I just want to kind of make this as interactive as possible. I think things work much better when we talk and when we chat. So I wanted to maybe ask you if you can all quickly just introduce yourself, how you have used Excel before, and also what drew you to this workshop, and are there any specific learning objectives or outcomes that you have that you would like to accomplish today? Or if you're just kind of here to listen and just kind of follow along and see what happens. So I can do it either by calling on you, or if you want to, please feel free to just unmute yourself and just introduce yourself. What do you prefer? Let's see if somebody's brave and we'll go first.
Hi, Mike. Well, you know me. I'm just here to see if I can learn anything new. I think I'm pretty good at Excel, but I saw this was advanced, so I thought maybe I could pick up something new.
Awesome. Hi, Ali. Thanks for joining.
Thank you.
Hi, my name is Sarah Martin, and I do work for FSU at the Controller's Office. I use Excel a lot for my work. And also, I am in the MIS program, currently in the graduate program. And the purpose of taking this training is I would like to know more tools to improve my work.
Okay, perfect. And Sarah, I'm just going to say if there's anything that I'm talking about, or if there's a formula that you're curious about, or somebody in your work uses that you're also wanting to know more about, feel free to either share this way or just put it in the chat, and I'd love to see that.
Perfect, thank you.
Yeah, right, and that leaves one. Not sure if I'm gonna pronounce it right, but is it Lucia?
Hi, can you hear me?
Yes, I can.
Hi, sorry, this is Oh Ha Wang, and I'm a biostatistician and data manager in the College of Medicine.
Okay.
And I use Excel every day, but just simply And I use some software like SAS, SPSS, and some other software to do data analysis and data management.
Mhm.
But I'm thinking Excel should have a lot of tips that I don't know, just want to dig out.
Absolutely.
Yeah.
Okay, great.
Thank you.
Thank you. Thanks for being here today.
Yeah.
To see if you have anybody else on the call. I don't know if Jesse, Nick, or Emily, you want to say anything yourself?
I'll say that I'm excited. This is Emily speaking. I'm excited to learn some little tips and tricks with Excel.
All right. Awesome. All right. Nick and Jesse, who are my other co-hosts and conspirators in the data series, unless you have something, I'll just move forward. One thing that I think is important to note is that I think in that switch from finance to academia, what really impressed me is how flexible and powerful Excel is to really meet the different needs of data analysis across all the different disciplines. But you do have to keep in mind that it's not Stata, it's not SAS or SAS, it's not R or any other dedicated tool for academic data analysis. So there are definitely limitations to Excel, but a lot of them have also been addressed over the last few years. So Excel has really become a very powerful tool. So let me run through some other slides. So here, I guess the first question that I want to just quickly establish is why Excel? And all of you have some experience already. So obviously we store and organize data, we analyze data with it, and then we have the opportunity to represent data graphically in a variety of different tables, charts, etc. And I mention this in particular because I think there is an emphasis that I want to make that Excel actually serves a dual purpose. And a lot of people don't think of the second purpose. Most people recognize Excel for the ability to organize and analyze data. But people kind of forget that it's also a presentation tool. And a lot of the visualizations that you have in Excel are really what makes it also so powerful because it's all integrated into one. I'll show you a quick video in a second about why I think it is A, powerful, and B, easy to use. And we can get into that a little bit more. I also want to quickly review this. This is something I start all of my Excel workshops with. Just a quick reminder of what I think, at least, these are Mike's rules for keys to success with Excel. The first one is that you have to practice it. It's like everything else. If you don't practice it, you just don't get better with it. So you need to find use cases, either in your own research or with data sets or in your private life where you are getting exposed to Excel and you are seeing what happens, and then you can also get to the advanced pieces. You need to understand the language of Excel. So when Excel talks about arrays or rows or columns or cell references or whatever, the way that formulas are described, Excel has a very specific language. But once you start understanding that part, Excel becomes a lot more accessible because you can do what I say in the third point, is you can start finding out things. You can Google things, you can hop onto YouTube. There are a bazillion different tutorials that people have created over the years. And the key is really to understand that nobody knows everything about Excel, and you will likely not be that person either, but somebody has thought of a problem that you are trying to solve. So if you understand how people describe it in Excel language, it will make it much easier for you to also find the solution that somebody else has come up with to see how they solve the problem, and then you can figure out how you can adapt their solution to your data set. And the last thing that I also want to remind people is to kind of be kind to themselves. There's no perfect way to do something in Excel, in my opinion anyway. There are just ways that you can do it fast and slower. And the example is that if you want to do a copy and paste, you can click on the copy icon and then you can paste with the paste icon. You can also use a right click on your keyboard, on your mouse, and you can copy and paste by right clicking. But you can also use keyboard shortcuts. And that's just 3 different ways that you can very quickly navigate Excel. And there are many other ways that you can either use complicated or simple formulas. You can use some of the pre-built formulas that Excel has and functions that are pretty much mini macros, or you can manually hand code things. So there are lots of ways that you can do things that will just show your proficiency and how you're approaching it based on your knowledge. However, while there is fast and slower, there's also right and wrong. And so one of the things that I would always encourage you to do is also when you're doing data analysis, especially on more complex data sets, is to try to have some checks and balances. So try to find different places to calculate sums, averages, do counts on how many items you have, just to help you see if you can have your checks and balances, like I said, to eliminate any human error or Excel error, which also happens. I want to show you this video over here next, and I show it particularly because I love this kid that you're about to see. I love him because he is not afraid to try Excel, and I love the joy that he has with Excel. So I'll just play a couple of minutes of this because I think it's just cool to see what this kid has figured out with the help of a background. So listen up.
Hey, welcome to Isaac's Excel bar. All we have to do is click this, and we have to hit this, and we say R, and then you click on this, and then you hit Control Enter, and then you go like this.
And what's the name of that little thing?
That's called the Angry Rabbit. If you want to add more, you can. If you want to add a lot, you can. That's how far you can do it. So if you want to do this, yeah.
No, cancel.
Cancel. If you want to do this, you can. You can do it every one you want. If you want to do this, there's a lot. There's a lot of choices, actually. There's actually a lot of choices. You can have a lot, and lots, and lots, and lots, and lots, and lots.
And then you pick one.
You want to pick one. You're not really sure you want to pick one to be, but...
And then show them how to change it.
If you want to change it, just click another one. Watch this. It changed.
And then, what about making the numbers and colors change?
Here.
F9 key, right?
Huh? Okay, F9. We're going to F9. Boom, 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 boom. It flickers and flickers and flickers until you're like flickering. It's flickering forever. So, if you see a white, if you want to make a chart, all the green, you can't.
And then show them how to make a chart.
A chart? That's easy! So, if you want to do it, you have to click the last one.
And what kind of chart is that?
A balloon, a bubble chart. So, if you want more than that, you can do that. Oh, jeez.
And then show them how to change the chart with the F9.
Watch this.
And you gotta let go of it, and because the chart takes a while to calculate. You have to let go of it for a while. And then hit F9 oh, there it is, look. And then one time, just one time. It takes a while.
Da, 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 da,
all right, and now tell them bye.
Bye, bye, bye.
So I show you this video because I think this kid is super cute. And I think that when he screams out, Excel is easy, that's like my favorite part of the whole video. And I want you to be like that kid because I think a lot of people are just afraid with Excel to work with it and to accidentally mess something up or whatnot. So you don't have to be afraid. Everybody can do it. It's that easy. Now, the other thing that I like about this video is that it shows you how Excel obviously gives you suggestions for formulas when you put in the RAND formula. Shows you how you get previews when you're doing things like the conditional formatting. Inserting charts is really easy, and everything kind of happens on the fly. Plus, this boy, his name is Isaac. He's 4 years old at the time. This was in 2011. So he's probably going to be an undergraduate somewhere soon. But he also knows about copying formulas. He knows about using keyboard shortcuts like F9 to recalculate a random formula and all that. So I think there's like just a lot of awesome lessons in this one. And I saw a couple of you wrote some messages in the chat, so appreciate that you liked it as well. So coming back to the topic at hand, which is data management. And so just a sort of housekeeping or good habits thing about data management in Excel is that you want to keep track of your data and the versioning of it. Typically, I would recommend creating new files or tabs with data that you've cleaned or analyzed. And quite frankly, never modify your original data set. Always preserve a clean copy because computer and human error do happen. And it's really difficult if you ever need to go back and you'll never know where you started if you have modified your original data set. Lastly, I would also recommend keeping track of the steps that you're taking in modifying your data. So to the extent that you can, keep some kind of a data coding sheet or a change log somewhere if that makes sense for the effort that you're going through. With that being said, and you know what, I realized I'm actually kind of, unfortunately, when I worked on my slides, the wrong data, sorry, 1 second. I just realized something that, I guess Excel got the better of me. Somehow my Outlook, my OneDrive didn't sync properly. This is actually not totally the wrong slide deck, but it's not totally the right slide deck either. So hopefully my data examples sync properly from yesterday. But anyway, we'll figure that out as we go through. So the first thing that I want to look at with all of you is the lookup and reference functions in Excel. Let me just ask quickly before I go there, are you familiar with these? And if you just want to give me a yes or a no or a thumbs up in the participant window, that would be helpful just to kind of know if that is something you are already familiar with or not. All right, I get at least one yes. And another yes, okay. All right, and I like that Jessie says they cause her grief, so she comes to me. So hopefully I can degrief them and ungrief them. So let me flip over to the Excel example, which is right here. And I will have later for you, hopefully this will work. I have a practice worksheet, so we can hang out for the last part of the workshop and you can try working on these yourself, either in your own time, or you can always reach out to me. So the first function that I want to show you is a VLOOKUP. A VLOOKUP is, the V stands for vertical. And what a VLOOKUP does is that it looks in the left-hand column, or the most left-hand column of a data table, and it evaluates the results in this data table. And then what it does is it retrieves from the table, from another column, a result. So to give you an example, we have a simple table. I have not labeled this table. There's nothing fancy to it. And you have column 1 has 1, 2, 3. And then you have values in here, 10, 20, 30,000. And then you have letters A, B, C. And if you enter the number 1 in here, it retrieves 10,000. And put the number 2, 20,000, and that is the number that corresponds from over here. And then, of course, if you put the number 3, it will put in 30,000. Now, when you do that, I'm working with exact numbers right now. And there's one more caveat that I want to show you, which is I can put in the number 4, and in this case, it still shows me 30,000, even though there is no value here. So in order to explain this, I'm going to just open up the cell to kind of show you how this is constructed. So all of you are advanced, of course, so you know that a formula in Excel starts with an equal sign. Then you type in VLOOKUP. And then from here, you are basically establishing what we are going to look for. So we're looking for the input in C7. We are looking for the cell references here, A3 to C5. So that's the table we're looking up. And then we're returning value from column number 2. So this is the first one where we're looking. If there was a number on top, this would be the first one. This is the second one. This is the third one. So if you constructed it, we would type it in, equal sign, V, lookup, that's the formula name. And then, oh, I should mention one more thing, which is I'm working on a Mac. I know if you're working on a PC or on a Mac, Excel on a PC and Mac are very different beasts. But I find a lot of people, and in the past I would have always taught Excel on a PC, These days I find a lot of people have Macs, they have MacBooks or the bigger computers. And so I like teaching on this as well. And a lot of the core functionality, the name of the function, the way the guts of Excel works, so the putting an equal sign for a formula and the title of the formulas do not change. But the look of your Excel is probably a little bit different than mine if you are not on a Mac right now. So just keep that in mind as we're working through this. But the basic functionality should all be very much the same. In any case, so when I start typing up the formula, I can put an equal sign, VLOOKUP. If I click on VLOOKUP, it gives me a wizard over here that tells me the expected values that Excel is looking for. So I can construct it by clicking on lookup value and selecting cell C7, which is I've marked in yellow. Then, of course, to give it the next input, I put a comma. And then I select the table array. So I select the entire array of the top left-hand corner to the bottom most right-hand corner. And this is very important that you keep that in mind, because as you are working with tables, as you're maybe copying formulas, as you're dragging them across, you want to be careful that your cell reference to the table stays appropriate and connected to where it is. If you have a static data set, you might be a little bit less concerned, but you might also be doing VLOOKUPs or HLOOKUPs, as we look at in a second, at in a data set that's actively still building. And so when it does, you want to make sure that certainly your most top left-hand corner stays the same. And the most bottom right-hand corner should hopefully also be the same, or you might have to update it depending on how your table builds. Then you want to have a column index number. And again, I mentioned the first column is the one where you're looking up in the most left-hand side. The second column is the one with the numbers, and the third one here is the one with the letters. So I'm going to put in just simply the number 3. I hit enter, and of course I get an error message because in C7, where my lookup value is, I haven't put anything in yet. So if I put the number 3 here, you should expect to see the letter C, and it works. Let me pause here for a second, just so I can check in with all of you if the speed is okay, if you're hearing me okay, if you can even see the examples, and then I will show you a couple more things on VLOOKUP in a second. So just give me a thumbs up or a quick comment in the chat, or you can just speak up. Okay, good. And I guess the other thing is also if I'm saying something and if I'm too fast or too slow or not clear enough, like feel free to just send me a signal and I'll pause and I'll look at what you're offering as comments. Good. So I mentioned before, so if I put in the number 4 up here, I still get the letter C. And the reason why is that Excel, in the way that the formula is constructed, and if I open up the formula builder here on the right, so just by clicking the FX button, you can see there is a last cell, a last part of the formula that I did not fill out, and that is the range lookup. And if you're not sure, you can always look here in the right side, although mine doesn't scroll, so let me just click more help. And you can see in here that as you're going down, oh look, I didn't even notice they have an X lookup now. Huh. All right, that'll be for the next class. I have to play with this one. Sorry. Is that the last value is that you want the true or false. You want to know whether you're looking up an exact value or you're wanting to let it find the nearest value. And the reason why this is important is if I go into my formula and in the last value here, I put in true, and you see I just enter it, it's only a binary, it's either true or false. I click done, and I still get the number 4, returns the value C. If I put in false over here, I now get an error message. And the reason why is that false in the last stage of the range lookup forces an exact match to the query in the lookup value. Whereas true allows it to be the next value in the list. Now, why does this matter? If I had the values instead of 1, 2, 3, say this was 5, and say this was 10, and I have the formula with the 4, it forces an exact match to the lookup. However, if I remove that and the default is true, do you know which value we expect to see in the results? Anybody want to take a wild guess based on number 4? Going once, going twice. you're going to see the letter A because it is the first one. When I put in 5, it gives me B. When I put in 6, it still gives me B. Put in 9, it's still B. 10 gives me C, and anything above 10 will always return the letter C. So what it does is, it goes down the list and says, what is the best approximate match to what we have until we hit the next value marker? So that is the difference between putting that last criterion as true or false. So again, if I put it as true, which is the default, it will seek the next match. If I put in false, it will force an exact match, so that it will only give me something back if I have exactly the value that I have here in my lookup table. This is important for a couple of reasons, because when you're using lookups, I've given you a table where this is a really nicely organized list. So when you have a nicely organized list that's in ascending order, and the ascending order can be in numeric, or it can be in alpha. It cannot be alphanumeric mixed. But as long as you're in an ascending order over here, and the VLOOKUP recognizes formats such as date and other things in there, sometimes in an ascending order, I can go to the next approximate one. However, if these numbers were, say, 10 and then 1 and then 5 over here, Excel, even with the false removed here in the back, would get really confused. Because it would see 1, it would bring me back a B, because it runs down. 2, doesn't recognize it. 3, so it just brings me the next value until it hits another marker. You see that? So only when I get to 10, even there, like it still returns C at the end because it's confused about where it is. The other thing that you need to keep in mind is, as I mentioned, when you're copying the VLOOKUP itself, remember the angry bunny? You can just drag down a formula. You need to make sure you're fixing your lookup values, right? So what I need to make sure is here, I am still looking for the value that's in C7, not in C8. This would be the same thing. I need to modify this and look up the value in C7. But the other thing that you're also seeing is that my cell reference has moved down. And so now I've lost my opening cell at the top of the table, array, which is A3. So if you want this to work, you either need to manually adjust it, or the alternative is that in your first formula, you're going to be using the $ to fix the reference to the first cell, and the same thing over here. If you're familiar with $, what it does is it creates a fixed cell reference. So now I can just always drag it down, and in theory that should have worked. Where did I go wrong? Oh, I didn't fix my C7 with $, sorry. There we go. This is clearly user error when something like this happens. And so when I copy this down, the formula now stays the same. So even though the table array has expanded to go all the way down, these values are insignificant because there's nothing there in them. But I'm still starting in A3, and that is really the key for starting with the VLOOKUP. I see in the chat a question about where did the formula builder come from. So let me just quickly address that. When you're here in results, like in cell C8 in my case, and you click the FX button that's next to the formula toolbar right here, the entry, it pops this up. If you're on a Mac, it looks like this. If you're in Excel, it will actually pop up a window in the middle of your screen that will give you the same information about what are the expected values. There's a description down here because of the sizing of my window. You can't see this. And then in Excel on a PC, you also have the more help on this function, which then pops up a browser. Sorry, I moved the wrong thing. Which then pops up a window like this one, which will help you get more information. And just so you know, I'm really excited about XLOOKUP. I'm going to have to look this up because this X or cross lookup is probably going to replace VLOOKUP and HLOOKUP in the future. So let me give you a more complex look at how a VLOOKUP works on a bigger data set than the one that we have right now that we're working on. So I'm done with this tab, and I'm happy to come back to it if you have questions, but I'll move on to this one. So I downloaded a table of aluminum future prices that I picked up from Yahoo Finance. So nothing very sophisticated, everybody can go there. No special requests required. This table has 6 columns across the top, 7, date, open value, high value, low close, adjusted close, and volume. You don't have to be a finance expert. This is more just for illustrative purposes. And you can just see that the data table starts here on October 9, 2019. So this is a year's worth of data, and finishes out on October 8, 2020. In that time, if you remember, the closing value is really where what we're looking at in finance. It went from 1743 to 1826.5, but in the time in between, obviously there were price fluctuations. So this is a pretty typical example of the kind of data that I think you might see and that you might want to be working with. So in order to work with this, I recommend that, as you can see, I've got a tab that's called VLOOKUP Raw. You can name it whatever you want, but this is the raw data file for me. This is the file, as I mentioned before in my good habits, that I would never want to change. This data set should stay pristine in the way that I downloaded it. No adjustments, no modifications. I copy that data over here to create a VLOOKUP formula toolbar. It's data set. So this is the one where I put formulas. This could be a workspace. Again, you can use any naming convention that works for you. But really all I've done is I've gone over here using Control Shift and the down arrow. I found the bottom of the data set. I found the right edge. Nothing more. I Control C, Control V, copy and paste. It's over here. It's the same thing. Now, I put some hypothetical questions over here that I think I can answer with a VLOOKUP. So the first thing that I'm asking is, what are the open and close prices on a specific day in the markets? So I want to retrieve a value in this column, column B, which is open. I want to retrieve a value from column E, which is the close. And I want to do it based on the input from a date field over here. And that is an application of how you might want to build your VLOOKUP, a kind of place where you want to use it. And you can use that information in a modeling exercise. So if you were building a financial model that is contingent on a price, an interest rate, a value on a specific date or something like that, that's how you would be able to use that. So what I've done is I use yellow as my marker for where my data input fields are going to be. And over here is where I'm going to put the formulas. And I've already built them. So you can just see it's pretty straightforward if you follow the earlier example. And VLOOKUPs are one of those things. The first one you're going to do is going to be horrible to build because it doesn't make sense. The second one will get easier. By the fifth one, you'll be able to build them on the fly, no problem. So what do I want to do here? I'm going to start with an equal sign, VLOOKUP. You can see it gives me now the most recently used functions and then just the functions as is. You can use this, or if you're comfortable, and by the time you'll be doing this a few times, you'll just know the syntax, which is the lookup value is here. Your table is going to start in A3. Again, you're going to use Control Shift down and to the right to establish the table array. You get the confirmation by this being highlighted in dark blue about where you are in your formula builder. And of course, you're going to see the update up here as well as you are in the toolbar as you are building your formula. Then I'm going to go back to my column index number. So to review that, I'm just going to go to the top and I'm looking for the open value. So again, I start counting from my most left-hand column as column number 1. Open is number 2. So I put in the value 2. And then again, it's your choice. The default is true, which is going to find the next precise match, or you can set it to false, whichever you want to use. False will focus on getting you only the exact matches. In my case, for this, I don't care because I know I've got exact values and I've got everyone covered. There's nothing in the middle. And then I put in a data point here. And so I use 1010 and you can see it's 1752 over here. It's 1752 over there. If I change this to 1013, and I got to be careful because if I do 1013 like this, I get the value from October 13, 2020. So I need to make sure that I adjust this and I make this 2019. And so you see I get the null value, and that is because that was entered here. So what the VLOOKUP does is it literally just retrieves the content of a cell in a table that is in the same row, somewhere across in another column. So if I go back and I change this to say 10, 11, so now it pulls 17, 17, 25, and that's the same value here. And now I'm going to do the same formula for the close. So VLOOKUP, oops, it helps when you can spell. I'm going to set the same lookup value. I'm going to set the same table array. I'm going to select the value. Now again, I got to go pick my column index number. And it's 1, 2, 3, 4, 5. Close is number 5. So I just, oops, click number 5. I close my bracket or my parentheses, and there we go. And you can see it's 17, 17, 25 here, same value over there. And then once I've got it set, I have now answered part 1, which is what are the open and close prices on a specific day. The second question that I kind of hypothetically placed is what is the gain or loss between two specific calendar dates if you bought at open versus the close. And so you can take some look here, and really simply all you're doing is you're just copying down the formula. Now, in order to make sure that you have to make less adjustments, I would recommend that you go into the formula toolbar, hit the $ in front of A and in front of 3 on the first one. And you don't really care about the bottom right because there's no new data. So even as you drag down and adjust, nothing's going to change. And you can do the same thing over here. If you're really lazy, it will even be enough to just fix the reference to the row. You don't need to fix the column because you're not dragging across to the right or to the left. You're just pulling down. So really, that's all you need to do. And so now when I do this, I can see that on October 11, we have 17, 17, 25. And then I'm just going to do a spot check, a visual spot check. And November 11, which we have over here, is 1794. And then I just put a very simple formula in to calculate a profit or a loss. And you can see if you bought on November 11, sorry, if you bought on October 11, sold a month later, you would have made 76.75 in profit if you had one contract on this aluminum future. And then I did the same thing for the close. And this is dynamic, right? So if I change this and I change this value to, I don't know, 7 dash, so July 8th, for example, just a random date, you can see that on July 8th, the value was 1642, so you would have lost money in that scenario. So that is really how VLOOKUP works. And it's one of the ways that you can work with pretty large complex data sets in order to retrieve values anywhere in it. So again, the key things to remember is that a VLOOKUP is a vertical lookup. Vertical in that it takes the most left-hand column of a table that you specify. So the table doesn't have to start in column A. It can start at B, C, D, wherever. It's any table, and you set that starting most right-hand corner of that table. And then what you do is you give it in the lookup formula, you have to decide which value you're looking up. In this case, I'm using a date value. You set the table array. You tell it then to go across to the right, so left to right, and you just simply number off 1, 2, 3, 4, 5, 6 from wherever your first column is. So again, if you start in A, it goes with the alphabet 1, 2, 3. But this could start in C, and you would still go 1, 2, 3 across, fairly straightforward. And then you just have to remember whether you wanted to pull an exact value, and you do that by using the false delimiter at the end of the formula as a range lookup logical question, or you can leave it blank or put in true, which will get you the next value that meets the criteria. Any questions about VLOOKUPs? I want to make sure I'm not going too fast or too slow or I'm boring you, but let me just check if there's anything that you want me to go over again or explain.
Mike, I got a question. I think they sent it privately to me. But the question is, if there are too many columns, how do you easily count column index?
Great question. I'll show you a really simple and very unsophisticated trick. This is the spreadsheet where you can mess around, right? So you put the number 1 on your first one. You get the angry bunny ears. You hold down the control key. If you're on a PC and on a Mac, you hold down the option key. You drag across, it counts it out for you, and that way you know close is 5, 3 is high, 2 is open, 6 is adjusted close, and so on. Nothing fancy to it, but I tell you, sometimes the best solution is the easiest one in my book. I hope that helps. Any other questions? And that's a very good question. A lot of people get really tripped up with, so what number do I put in this column index number where I just have the 2 over here and then the 5? I think that trips up a lot of people. So that's a great question. All right, well, let me show you HLOOKUP. HLOOKUP does the same thing as a VLOOKUP does, but the H, as you would probably expect, if V stands for vertical, H stands for horizontal. And so an HLOOKUP does the same thing as a VLOOKUP, just across the top of a table. So rather than going down the most left-hand column, you're now running across the top, and you're retrieving a value from somewhere into the columns. So to give you an example, 1 will produce the value 100,000, 2 will produce 75,000, 3 will produce 50,000, 4 will produce still 50,000. And this is all the same logic as before. And HLOOKUP follows the same syntax, where you put in the lookup value, the table array has to be specified. It starts as with the VLOOKUP, and the top left goes to bottom right. And instead of a column index number, you now have a row index number. And the logic for counting them out is exactly the same as before. Your first row is row number 1, 2, 3, 4, 5, 6. And if you want to keep track of it, just like I did in the VLOOKUP, just put a counter on the side that tells you which row you're in. And then you have the true false. So if I put false in here, I don't have to worry about capitalization. Excel will do it automatically for me. I get an error message now at 4 because there is no value number 4, and I'm forcing an exact match. So 3 works, but 2.5 will not work, but 2 will work. Right? You see that it pulls these values from here. And if I remove false again, then you will see that 2 gets me 75,000, 2.5 still gets me 75, 2.999 still gets me 75. As soon as I add 3, it finds the next match, I get 50,000. So that's an HLOOKUP. It does exactly the same thing, just across the horizontal as a lookup, and then it goes down as opposed to vertical, which goes down and then to the right. Any questions about HLOOKUPs? Like I said, it's fairly straightforward, and I'm going to pull this up again. I'm excited for XLOOKUPs, which I'll play with after this class is done, because I'm terribly curious to see what they've created there. Oh, hold on. My sharing window keeps on. Come on, don't do that. Sorry, I can't get my, there we go, now it's gone. That's how these ones work. All right, let me see, I'm not seeing any other questions. If that's the case, let me move on from VLOOKUPs and HLOOKUPs, and we're gonna look at something called filters and subtotals. These are 2 of my favorite functions, I have to tell you. Filter is a really smart tool that I think is significantly superior. Oh, hold on, where's my filter example? There it is. Which I think is significantly superior to the sort function that you have in Excel. It kind of lives in the same space. So when you look at it, you'll, you might not realize it's there. So I'll just show it to you, and I'll explain to you why in a second. So this is data that I downloaded from one of our library databases, which is CQ, what do they call it? There it is, CQ Press. They have a political stats database. This is data on the Keystone Pipeline passage. This is something that happened a while back, and thank you, Jesse. CQ stands for Congressional Quarterly. And it basically looked at the passage of the Keystone Pipeline and how across, I guess, I don't even know if this is the House or Senate or whoever voted, but anyway, it looks at how they voted. And you see that the information on the left is sorted by state. So you got Arkansas and Alabama and Arizona and everybody. You can see the districts are numbered. You can see the individual who's the representative there. You can see the party affiliation, and you can see how they voted in this passage of this bill. As I said before, I like to keep a raw file, just data completely in its pristine, unaltered state, the way I get it when I receive it. And then so I copy it over here to have this information. So a couple of things that you see, which is one, Excel throws up an error message here, and it says this cell number, this cell is formatted as text or preceded by an apostrophe. So if it mattered, I could convert this to a number, but I don't really care to. And what I can see, what I've done already here is, let me take it off actually, just so you can see how I get there, is I've applied the filter. And the reason why filter is important is, and the way you do it is you can do two ways. One is that you highlight your column headings, or you just select the entire row. In this case, I'm just going to use my column headings. Then I'm going to click here on the right where it says sort and filter. And if you're on a PC, you might have it a little bit different. I think it's kind of jumping off the screen a little bit, but hopefully you can still see it. And you can see you have the basic sort A to Z, Z to A. Then you have the option for custom sorting, which allows you to expand the whole section. But what we're going to do today is we're going to use filter. So what filter does, it actually creates this whole content as a drop-down menu, which is really neat. And this is actually the same kind of logic that now drives things like Power BI and other Microsoft tools that are used for advanced data analysis. And what I like about it is that it creates for me basically a sortable database that I can filter by different criteria. Whereas sorting itself only allows me to sort and not filter. So what I can do is I can look at state, for example, and right now it's sorted in ascending, but I can very quickly shift it and reverse it by clicking descending. I can go back to ascending. I can deselect and say, I just want to know how Arizona voted. And what it does is, you can see here on the left, it keeps all the data, but only shows me what I selected. So if I want to see Colorado against that, I can compare very quickly how Arizona and Colorado voted on the Keystone Pipeline. I can also do other things, which is if I go and select my whole again, is if I had, for whatever reason, applied some conditional formatting, and this one was yellow, and this one was yellow, I can now do a couple of things. One is I can sort by cell color, and so you will see that my yellow's at the top. But I can also do a filter just by selecting my yellows. And again, depending on how you're using your data and whether you're using colors, for example, which could be generated from conditional formatting or whatever, you have the option to it. If I click clear filter, it goes back to here. And if I click it back to ascending, I'm back into my original. And then I'm just going to take off the highlights because I don't really care for them in this example right now. And then I can see it. The other thing that I can very quickly see is all my data points have been now sorted into unique data fields. So all states are now represented over here. I can see how many districts there are, and it does use the convention where it goes 1, 1, 0, 1, 1, etc. So to see the 2s, you go over there. But I can see that the state with the highest district count has 53 districts. And if I want to see which state that is, I can very quickly, some of you may know this, I personally don't, so I can just click here, and I can very quickly see California is the state where there are 53 districts. Now, it retrieves all the information from that table for me, and I can see it was Susan A. Davis. She's a Democrat, and she voted against the pipeline. If I click clear filter, I get all my data back. If I want to see how many parties voted, well, in the US, we only get the Democrats and Republicans voting, so I can very quickly see all Republicans. I can see all Democrats by just sorting, unsorting. And then I can actually see how they voted. And I can see there are people who voted yay and nay, of course. Some voted just present, some did not vote, some voted announced for, and some announced against. I'm not a political scientist, so I can't tell you the nuances of this, but it's not important for this Excel analysis. Because really, I'm just trying to show you how I can take a large table with a 440, almost 440 lines, and very quickly get some very fast information from it. So now that I have this table, I can also do some other things, which is I can select a state. So let's take California, for example, because California is the big state with 53 voting districts. And so I've got all my 53 voting districts in California here. I can now filter it by only saying like, okay, well, how many Democrats voted? Sorry, how many Republicans voted? I can see these are all the Republican representatives in California. And then I can see how they voted. And if I want to see who did not vote, I could do that, and I can see 3 of them just abstained from the vote. So what I can do is I can very quickly drill down. And what you'll notice is that where I did not do anything to the field, it still is down pointing triangle or arrow. And where I've applied the filter, you can see that I've got the filter set up at the top. And now that I've drilled down, I can also undo the filter. So if I want to see all Republicans that did not vote, I could just clear this filter, and I can see that Republicans in California, Florida, North Carolina, Ohio did not vote. If I want to see across the party lines who did not vote, I can just clear the filter here. Let me just move this up so you can see. And now I get all people back. And so I see everybody who did not vote. And if I clear this filter, I get my whole data table back all the way from all the 440 rows. And so you can very quickly run through all of this. It's the reason, as you can see how quickly I can drill down into data and how quickly I can extract data. That's the reason why I prefer using filter over sorts, because in a sort, I couldn't do it as quickly in a back and forth. Now, here's some other stuff that I want to do now. I've posed some hypothetical questions. So how many votes were cast in total? There's a couple of different ways to count these, but the easiest way to do it is by seeing how many people are represented, right? So if I did here, the formula for that would be count A. It's not count, it's count A that will count all non-numeric values that I have in here. So actually all non-blank values, sorry, I should say. Whereas count will only count numeric values. So you have to understand the different count functions. And if you're not sure, you can go over here to where it says formulas, and in Excel. On a PC, it's a little bit different than on a Mac. But you have your different lookup functions here, for example. You have different text functions that you can use. You have the logical functions. And here you've got the financials. And really what I'm looking for is somewhere in here, it should be the count. I actually don't know where they are right now in this subset. Are they in here? Yeah, you can see all the counts under statistical. And so what's neat about that is that you have count, which is count numeric values. You have count A, which counts non-blank cells. You have count blank, which only counts blank cells. You have count if, which only counts if a certain condition is met. And you have count ifs, which only counts if at least 2 conditions are met. So you have a whole number of different ways to count. I'm going to use the count A function here first. And if I do count A, and I select this whole data set, again from top to bottom, E6 to E440, I can now see there were 435 votes cast. Now, that is not totally true related to the question that I've asked, because what I said is how many votes. But we do know some people did not vote. So really, that's not the true question. So what I want to do is I can actually turn this count A into a count if. Oops, I gotta start with an equal sign, of course. The range that I'm going to check off is here. Again, same range always. And then the criteria I have to put into quotation marks. I have to type it in yay, the way they voted. And then I can see there are 252 who voted yes. Now there's another way that I can do this very quickly as well, which is I can use a function called subtotal. And subtotal is one of those like hidden awesome functions that a lot of people don't realize exists. And so I'm going to open up the formula builder for you so you can see what it looks like. And subtotal works very simply. You're using a function number, and I've listed out the function numbers here on the left, so you can see that. And if you're using 1, you're getting average, 2 gives you count, 3 gives you count A, 4 max, 5 min, 6 product, etc., all the way down. And I've highlighted the ones that I use most because they matter to me. It's count, count A, and sum. And so I'm going to use for this one the count A function, which is 3. And then you give it a reference. In this case, I am going to count from the top again to the bottom. Oops. Why is it not letting me do that? Hold on, E6. All right, it's not letting me do it like that, so I'm going to do it like, hold on. I have to type it the way I would usually type it. So the function is 3, and then we've got E6 all the way down to E440. And what you'll see is that it gives me the same as the count A before did. Now, what I can do is I can go over here, and I'm going to only select the yay votes. And what you're going to see in a second is that this number here in the subtotal function has adjusted to 252. And what I like about this is, and what subtotal does is, it returns a subtotal in a list or database based on what you filtered for. So instead of having to modify yay and build a table that tells me all the yays and all the no's and all that kind of stuff, I can very quickly change this, and I can see, all right, how many people voted against it? Here we go. Minor problem with this one. You can see that my rows 5 to 13 have been filtered out. So typically you'd want to put this a little bit higher so you can see it. So let me pick a different one that's not in that same set of data. So maybe voted present. And you can see that only one person voted present. Actually, let me adjust my table a little bit, just so you can see that again. I'm going to move my questions actually up to the top above the table. All right. So if I wanted to see the no's, I can just click here, nay, and there we go. So now we can see 161 voted against. This number is still static because this one was set up with the criteria of yay. So if I change this to nay, it should also say 161. And this is a way actually that I'm showing you that you can also set up your checks and balances so that you can make sure that the calculations against each other work pretty well. So now I'm going to set up the same thing by party. So I clear the filter. I'm just going to set it up with the subtotal function here. So I'll just label this at the top. And so I'm going to, again, use subtotal as a function. And I'm going to this time, again, still use the count because I got to count how many people are in that field. Click 3. And now instead of looking at how they voted, I'm just going to select column D. And it still shows me 435 because that's all the votes. But now if I wanted to split it out, I can see there are 201 Democrats. And I can see there are 234 Republicans who voted in this one. And then again, if I want to restore my original data, I just click clear filter and then back to this one. And then, you know, I could further use this to break down the votes by party. So I kind of got myself twisted with the examples here. As you see, I mentioned my file didn't update totally properly, so I apologize. This is subtotal and filter, the functions that are living back here. Let me just slide this over so you can see it better. In your toolbar, again, depending on whether you're Mac or PC, they will be somewhere in that same area on the right side, but that's what you have to look for. So let me stop here again and ask, any questions about subtotal or filter? Are you using it? Is this something that's useful? I apologize, I know I'm just kind of running very quickly through a whole bunch of Excel examples, so I hope this is kind of flowing and making sense for you. All right. Thank you for that feedback. For one of you wrote in the chat. Okay, cool. There you go. So subtotal function not used before. All right, and Ellie's saying she's already familiar with these ones. Great. All right, I'll show you one more thing that I have on my list that I want to show you today, which is breaking up complex data strings. This is something that I find also, as you're doing Excel analysis, can be really messy. So sometimes when you get data from a data set that's not yours, that you've built, it often comes like in a CSV file. The CSV file will have something like this one, where it's like /. This is from a 3D printer system log, by the way. Says Sculpteo, that's what it's called, /, and then it's got some name, and then it's got an extension. And so the question is, when you get something like this that either looks like this, or it might look like, 123.456, then it might have date, then it might have a semicolon, then it says first name, then it might have another semicolon, and it says last name, something to that effect. Like sometimes you get data downloads that are really messy like that. So how do you break that up? Some people use text to columns as a feature, which lets you take that and redo it and kind of break it apart. But it can get messy when you have something, for example, where you get first names and last names, and some people might have 2 first names or 3. Some people might have 2 or 3 last names. And you have to do a lot of work to modify that, to break it out. And it's really hard to go back from text to columns to see if you're getting the right inputs and outputs. What I like doing when I get to these kind of things is using a range of formulas that are basically called, and let me just delete this for a second, that using a combination of formulas that are using length, which is len, left, right, mid, and find. And I'll show you in a second how it works. So I'm gonna go back to my data file, copy this down, and paste it over here. So what I'm doing is I'm looking at a string like this one that says Sculpteo, /Sculpteo /alumite.3pp. And when I look down this list very quickly, I can scan and I can see that's pretty much got the same format for all my 97 data points that I've received. Now, some people for something like this, they would use the find and replace, which is when you do the replace function, looks like this, right? I can go in here, I can type in Sculpteo, whatever, with the /, and I could just remove it from the data if I wanted to. There's nothing wrong with that, it works, but it's a lot more complicated in some cases where you don't have a unique word like that, or it's a text string that might repeat, or it's a number. So when you're working with a large data set that you can verify very quickly, that's problematic. Same thing goes for the .3pp at the end and all this stuff. So what I do is I like to actually look at this and see if there's any theme. And because these are computer generated, there's usually some kind of pattern that you can discern that was put in place to delineate where a text string starts, where the next one starts, where the next piece of information starts, etc. And what I've done is I'm using something called the find function. And I'm using the find function to see where, and here I'm just going to make it a bit larger, where that second / is. I don't really care about the first one because I know between the first and the second, for this data example, always says Sculpteo. What I'm looking for is the second one, and what I'm looking for is the relative position of it in the text string. So in other words, if the first / is position number 1, S is number 2, C is number 3, U is number 4, L is number 5, P is 6, 7, 8, 9, 10, etc. What I'm trying to do is I'm trying to find the relative position of this one by using the find function. And what I'm doing is, the next thing I'm looking for is where is the period, because the period tells me where the end of this text string is. So in this case, it's alumite. So what I'm doing is I'm using a formula called find. And what find does is it searches inside of the text string for a specified text and then returns the position, and you can tell it where to start. So let me write this from scratch. So I'm writing find. I'm going to use my formula builder again. All right, I'm using the formula find. Sorry, I have to click find over here. And now I can see I'm looking for find text. In this case, I don't have a cell that I'm referencing, but I could also, instead of calling it find the second /, I can just put a / and I can link to this. In my case, I'm doing it like this. And again, for text to be recognized in these formulas, you need to put it in quotation marks. Then it's asking, where do you want me to find this? And I'm going to put this. And I have an extra parentheses here. There we go. Oops. And then I got to give it a start number. And the start number I can set at 0. And if I, sorry, it did a nested formula. Let me just reset this one. So I can do find. And then I'm going to tell it which text I want it to find. There we go. And that's asking me within which text, and I can do this. And obviously, as you would expect, the first / is in position number 1. What I want is really, I want to know the position of the second one. So I can go comma, and I tell it to start after the first one, and I realize that it's 10 characters into the text string that I always have this /. Now, where it gets really interesting is with trying to find the first period. And I know there's only one period in all of these. And what I'm looking for is where is that? Because the distance between where that period is to that second / is going to tell me the length of the text string, which I need to retrieve in order to break out the piece of that 3D filament. So what I did is I typed in the formula as find. The text I'm looking for is, again, the period inside the quotation marks in this first text, and I get the relative position 18. I then simply subtract the second point from the first point to get the relative length. And now I have to retrieve the text string. So how do I do that? I'm going to use the function called mit. What mit does is, let me just update this here. It's going to say, bring me back a certain string of text in the middle of it, from a middle of another text, starting at this number, and it's this many characters long. So I'm going to retrieve from my cell A2 where that first data piece sits. My starting number would be here, right? You would think. Oops. It helps if I actually type the formula in. Sorry, I'm on a roll today with life examples. So I'm looking in A2. My starting number is going to be 10. And I've calculated the length of how long of the text string I want it to be. So I click 8. I make that reference. And now I'm getting this result. So the good news is I'm getting Alumite back. The bad news is I'm getting it with the /. So I want to remove the /. So the challenge to that is that you have to understand the relative positioning of where things are. And you have to realize that the / that I got over here, the value 10, is actually the exact position. And so that's where the mit function is going to start retrieving. So the way I fix that is by going d2 plus 1. Because now I'm telling it actually start retrieving from the 11th position in this text string. And now you can see it's giving me the whole Alumite string, but now it's adding the period because I've shifted it over 1. So now what I need to do is go here, F2, and -1 to reduce the length. And there you go. Now I get a perfect return. And now that I've built this once, assuming that everything stays the same, I can, if my mouse will cooperate, sorry, find the angry bunny ears. Why am I not getting angry bunny ears? 1 second. Come on, there we go. And I can just drag it down. And look at this, I have perfectly broken out every part of this text string. So Alumite, ceramic anise green, Aquarius blue, everything just the way I want. And now I've got a nice clean data set that if I want to work with this, I can just copy this. If I want to stick it somewhere else, I can right click, paste special, just the values. And now there's no more formula behind this. I've just got a really nice clean set of text that I can work with and do whatever I need to with it. Now, the function that I want to show you in this context are length. Length will calculate the length of an entire text string. So if I looked at how long is the content in A2, I basically would just equal len in parentheses A2. That tells me it's 21. I can also use left, which will return characters from the left. So I'm using A2 and 10. Right does the same thing from the right side. So I could break off, if I know the extension is always 4 characters, I can pull it off like that, or I can do it by using a combination of the length of the strings and the relative positioning of the period. Mid is the one that we looked at, and then find is the other function that we looked at. Let me ask you, how was this? Was this helpful? Is this something you know, have seen? All right, good. Super. I love it. All right, good. A little bit less than super, but still good. Thank you for the feedback in the chat. I will say, like, I tried to pick 3 things or so, like major areas that I thought were really useful for me as I work with big data sets. And what I wanted to do is just flip back to here. I was going to show you a thing on macros, but my PowerPoint didn't really update, like I said. Unfortunately, for some reason, the syncing did not do what it's supposed to do. Mostly what I was trying to tell you is do not use macros. I find they end up screwing up more than they help. There are very few routine things that can be turned effectively into a macro that you can't also do by using things like the lookup reference, the filter and subtotals, or breaking up data strings using these formulas. And people will often try to use macros for that. And people run into trouble, in my experience, that somebody builds the macro by doing a lot of trial and error, and then people, like whoever inherits it or even often the creator, do not remember how to fix a macro on their own. What I want to do quickly is I do have a practice data set that I can copy to all of you if you want. I'm hoping this will work. Let me just make sure it's the right one, because this is not the right one. Basically, I've kind of given you the same examples I've had. So if you're interested, we can do one of 2 things. I can share it anyway. I'm going to drop it into the chat. I hope that works here. Does that work? It doesn't work. 1 second. I have to upload it from my drive. Never mind. I'm doing a live example, and of course, nothing's working the way it's supposed to. So what I can do is I can, in a second, figure out how to send it over to you. But what I also wanted to do is just pause for a second and just see if any of you have questions or comments, any formulas that you know that are sort of vexing and you'd like me to see if I can help you with it on the fly. What would you like to do next? We've got about 15 minutes, and I'd be happy to either just have a chat or let you work on this example if I can find a way to get it to you so that you can work on it and I can help you if you have questions.